Hello everybody, welcome back. Today we're continuing with chapter 7. We're looking at 7.4 factor form of a quadratic function. We're going to look at the x-intercepts. We also call them zeros or roots when y is equal to 0. Zeros of a quadratic function can easily be found by using the factor form of the function. So if a quadratic function will factor, it's very simple to sketch a graph via factor form. Okay. So remember, this is the standard form here. Standard form is when we have the equation in, and I'm just going to take this for a minute. It's when we have it in y equals ax plus bx plus c. Okay, so a would be 2 here, b would be 14, and c would be 12. So we're going to do the factoring method here today. So the first one here, we'll factor it at 2. So you may recall, well, hopefully, anytime we would factor, we first factor out what's called a GCF. So I factor 2 out of here. 14 with a 2 factor it will leave us with 7, and 12 factor with 2 leaves us with 6. So we end up with this. Remember, set it equal to 0 as well. All right, because we're going to find the zeros. And then we'll factor here. 2 numbers multiplied together give me 6, added together give me 7. That's pretty straightforward. It's just x plus, and it doesn't matter the order, x plus 6 and x plus 1, right? So 2 numbers multiplied together. And that tells us that the x-intercepts are going to be negative 6 and negative 1. Okay? So we can say that x plus 6 is equal to 0. And we also can say that x plus 1 is equal to 0. We don't have to worry about the 2. We've already factored that out. And that means that x is equal to negative 6. We add the 6 to both sides. So that's equal to negative 6 and negative 1. And negative 1. Right? Add, subtract 1 on both sides. Some people call this x1 and x2. I just look at them as we know there could be possibly 2 x-intercepts, and we go from there. Okay? So we will graph those on the prep. I'll show you that in a minute. Next, we're going to find the vertex. A couple ways to find the vertex. If you have the x-intercepts, and we're doing factor form, so we'll do that first. We do what's called the axis of symmetry. Axis of symmetry. And that is simply, axis of symmetry is simply to get the x value of the vertex, we add the 2 x values together. So we will, I'm going to call this, just for this exercise, I'm going to call it x1, y1, x1, or sorry, x1, x2, I should say, sorry, x1, x2. So all we do is we add the 2 of these together. x1 plus x2 divided by 2. So we simply average the values, so negative 6 plus negative 1. And that's all divided by 2, of course. Which is equal to negative 7 divided by 2, which equals 3.5. All right. Sorry, negative 3.5, my bad. All right. And to get the y value, just plug it back into the original. I'll get my original. Right. To get the y value for the vertex, just take the equation and plug in my x value of negative 3.5 squared, 14 multiplied by negative 3.5. Alright, and then we're going to square negative 3.5. So squaring a negative gives you a positive of 12.25. Multiply 14 by negative 3.5, and that gives me negative 49 plus 12. Double up the 12.25 gives me 24.5. Subtract 49 plus 12 gives us a y value of negative 12.5. So that means the vertex vertex is negative 3.5 and negative 12.5. Again, you can just check this on your, this is the algebraic work, right? You can do this on your graphing technology, of course, you folks know that. So we're going to graph this parabola, and we're going to graph this as if we didn't have the quadratic, right? Like we didn't have Desmos. We're going to graph it, but I'll use the Desmos program. So we'll put their x-intercepts in, so we get negative 6 and 0. We'll plot that, label that. Okay, there's negative 6, 0. Do the same with negative 1, 0. Label that. Okay, and then we had the vertex we just found was at negative 3.5, comma negative 12.5. There's a vertex, label that. Bottom there. Okay. And we also know the y-intercept is 12, 0, and 12, right? So we look at the original form of the quadratic. We notice that the c value, so we go back to the quadratic. C value right here is 12, so that means the y-intercept is 12. And then we're going to draw our line through, our equation through. So we have y equals 2x squared plus 14x plus 12, and we draw a line through all that. I'll make that red. And see how we just draw a line through? And there's your points there. Okay? And then you want to label them. There's my vertex. There we go. There's your graph. So enter our graph in here. There's the graph of the parabola. Okay. Another way to find the vertex x value is if it's just in the standard form. Okay, so I'm just going to say another way to find the vertex. Okay, so there's another method. We use what's called x is equal to minus b divided by 2a. All right, so again, remember form here. So minus b over 2a. So what we do is we go negative bracket what our b value is. The b value here was 14. Divided by 2 times a, which was 2. Okay. Which is equal to negative 14 divided by 4, which is equal to negative 7 divided by 2, which is equal to negative 3.5. So that's just another way to find the x value of the vertex. Okay. And we use that usually if it's in standard form. Now, if it's in factor form, it looks like this. It's pretty easy. You just take the symmetry. But again, it's just another method. And then the y value would be found using the same method. of how we found the y value, plugging it into the original. Identify the y-intercept. Remember the y-intercept, again, I'll take the original equation for those of you that still aren't sure, but it's just the c value when it's in this form. But remember, to get the y-intercept, remember, we let x equal 0, right? Remember? And again, you're going to see why we don't really need to do the math on this. So if we let this equal 0, we let this equal 0, we end up with 0. 0 squared times 2 is 0. 14 times 0 is 0. And 0 plus 0 plus 12 is 12. So that means that the y-intercept, right, the y-intercept is 0 and 12, as I indicated when we did the graph earlier. Let's look at domain and range for a minute. So this goes on forever to the left and to the right. So for the domain, there's two ways we can write it. We can say that, first we can say that x is an element of the real numbers, which you folks are used to. We've been doing that, right? Because it goes on forever. And it's continuous data. And for y, the y goes as down as far as negative 12.5. So for y, we have to say y is greater than or equal to negative 12.5. So its null value is less than negative 12.5. And again, you can use interval notation. Depending on how you were taught, there's interval notation as well, and you can use whatever you prefer. So we have square bracket, negative, infinity, comma, or sorry, round bracket. You can never have square bracket with infinity because it's it can't be included, right? So we can use that. For the domain, and then the range, what we do is we show it with, now this is where we show the square bracket. I'm going to steal this. Alright, so the lower number is a square bracket, and it's negative 12.5, and then it goes on forever to positive infinity round bracket. Okay, so you can show either one you want. So these are the domain, and these are the range, right? Okay, possibilities there. All right, so that's how we sketch a graph on a coordinate system using zeros and intercepts and vertex values. All right. Okay, so it's without the graphing technology. Of course, you can do the graphing technology to help you out. So that's it for this video. In the next video, we'll look at example number 2 from 7.4. Thanks everybody for watching, and we'll talk again soon.